afternoon. This is Rudra Pradhan here. Welcome to NPTEL project on econometric modeling. Today we will discuss multicolinearity problems. In the last couple of lectures we have discussed the details about the econometric modeling, that to bivariate analysis, trivariate analysis and multivariate analysis, and everywhere we use ULS techniques to estimate the models, and we consider for the fitness of the models so far as a best fit is concerned, and every times we start with OLS assumptions and end with checking all these assumptions. But perfectly we have not discussed anything in any particular problem regarding assumption till now. So today we will highlight one of such problems after the estimation through this OLS technique. So one of the interesting problem is called as a multicolinearity. Multicolinearity itself is a multivariate problems. Okay, so for the beginning we have started with bivariate modeling, trivariate modeling and multivariate modeling. So far as a bivariate is concerned, there is one dependent variable and one is independent variables, and that is the starting point of econometric modeling. But when we start with the bivariate setup, where there is one dependent variable and another independent variable, then obviously there is no question of multicolinearity. But when we move to trivariate model or multivariate models, then the problem of multicolinearity can be generated. Okay. So now we like to know how is that particular concept, what are the problem associated with this particular multicolinearity, and how we have to detect, and what are the solution for these problems. Is it genuine or is it mandatory that you have to remove, or you have to go ahead with these problems? That we have to discuss in details today's lectures. So the thing is that multicolinearity is a multivariate problems, and that too it is in the right side of the problems. So that means when we fit a econometric model, then obviously whether it is bivariate setup or multivariate setups, so every times y is in the left sides, that is considered as a dependent variables, and x's are in the right sides, that is called as a independent variables. If there is one x and there is y, then it is called as a bivariate. So when one y then 2x, then it is called as a trivariate. Then one y with more x means more than 2, then we call it a multivariate analysis. But if you start with the bivariate to multivariate, in every stage you find y is in the left sides, that is always considered as a dependent variable, and that too 1 every times. So that means we are discussing here the entire problem with respect to one dependent variables, and right now we will discuss so many problems again with respect to one dependent variables with one independent or many independent variables. But there is another system called as a structural equation modeling or simultaneous equation modeling, where the dependent variables cannot be one, so it can be many also. That means in the left side there is a series of variables y1, y2 up to say yn, and in the right side there is series of independent variables, say x1, x2 up to xn. So then we like to know how each variables are interdependent to each others. But when you go for a pure multivariate analysis, then the classification of dependent and independent may not be very handy, because when they are considering as a interdependent to each other, then it is very difficult to analyze which one is the specific dependent variable and which are specific independent variables. Okay. So that means even if in the x sides, if two variables are correlated each other, then obviously within the two variables one may be dependent and another is independent. So, that is how the problem is more and more complex. So, with this basic background, we like to start what is all about this multicollinearity problems. Okay. So, multicollinearity. So, the term itself will give an indication that it is a multivariate problems. So, now we start with a multivariate system, then we will discuss what is all about multicollinearity problems and how you have to sort out its solutions. Okay. So, let us start with a multivariate problem. So, for a multivariate problems, let us start with the y equal to function of x1, x2, x3 up to xk, okay, where y is considered as a y1, y2 up to yn, and x1 is considered as a x11, x12 up to x1n, then x2 considered as a x21, x22 up to x2n, and continue. Okay. Then xk is equal to, that means every time there is a obviously function, okay, function between, or you can say sorry, y is this much, then x is this much, is a set of series, then this is x1, xn equal to x, okay, we can call it xk, okay, xk, xk1, xk2, xk2, then continue xkn. Okay. So, this is how the system all about. So, that means we are considering a multivariate problems where there are a k number of independent variables and one dependent variable, that is y. Okay. So, where y has a sample y1, y2 up to yn, and x1 has a sample x11, x12 up to x1k. Similarly, x2 has a sample x21, x22 up to x2k. Similarly, continue for kth series xk1, xk2 up to xk1 kn. Okay. So, that means we are considering k number of independent variables and where n represents number of observations. So, by default the starting of these problems, so we have to assume, the standard assumption is that all the variables have same sample observations. So, that means for y there is n samples, x1 there is n samples, x2 there is n samples, and xk there is n samples. If the sample size is different for each variables or various variables, then obviously there is a serious problem. That problem is, means the problem itself is inconsistent. Okay. So, to make the consistent, you have to apply plus minus, to means you decrease the sample or increase the samples, then you make the structure where all the variables has similar sample size, okay, or same sample size. So, if it is so, then you have to proceed. Okay. So, now with this particular background, so what is our models? So, now we will fit a multivariate models. So, y equal to summation beta I xi I equal to 1 to n plus beta 0 plus u. Okay. So, this is the multivariate model. So, where y is a dependent variables, okay, then xi is independent variables, okay, beta is the slope to the independent variables, okay, then beta 0 is the intercept, that is otherwise called as a supporting component to this particular y, supporting instruments, or this is u stands for error correction, error terms. Okay. So, now this is the pure multivariate systems where y is the summation beta I xi plus beta 0 plus u. Okay. So, where y is the dependent variables, beta is the slope factors, slope components, xi is the independent variables, beta 0 is the intercept, and u is the error term, and this model is purely in implicit format. Okay. So, let it put it in a explicit format. So, it will be coming beta 0 plus beta 1 x1 plus beta 2 x2 plus continue plus beta k xk plus u. Okay. So, this is the pure multivariate models with k number of independent variables. Okay. So, now we have to see what is the structure of this econometric model with k independent variables and y dependent variables. If it is so, then how is the proper structure? So, that means the starting point is here y equal to beta 0 plus beta 1 x 1 plus beta 2 x 2 plus beta k x k plus u. Error term obviously will be always there. So, now this is the pure two regression equations. So, now the next step is to have the estimated models. For that we have to apply so many techniques like OLS, GLS, WLS, MLE, etc., etc. But till now what we have discussed is the application of OLS technique. Again we have to discuss here also OLS technique, and we have to see by using OLS technique how quickly we can have the best fitted models. So, the moment we will apply OLS technique, then the technique itself based on certain assumptions, and that assumptions will lead to lots of serious problems. So, this is one of the assumption we are going to verify with this particular multicollinearity problem. So, I will highlight what are the assumption and how will come to this particular multicollinearity issue. So, in the meantime, our standard multivariate model is like this: y equal to beta 0, beta 1 x 1, beta 2 x 2 up to beta k x k. All right. So, now after OLS technique, then the model will be transferred to estimated model. So, then accordingly the estimated model will be y head. We call it y head, where y head equal to beta 0 head plus beta 1 head x 1 plus beta 2 head x 2 plus continue beta k head x k plus u. So, this is the standard estimated models. Sorry, u is not here, because the moment you will estimate, then obviously you will be removed. The way we minimize the error sum squares, then we will get the estimated model. So, obviously in the estimated model there is no such u component. U component is only two regression line. We like to know what is the percentage of u involved in this particular models. If the percentage is you can say very high, then the model cannot be considered as a best. So, the percentage, if the percentage is less, means u impact is very less, then the model can be considered as the best, provided other things can be on the right track. So, in the meantime, here our basic objective is to check what is the error sum, and we every time we have the objective to minimize the error sum squares, and the way we will minimize the error sum square, we will automatically get the best fitted model. That is the process, or you can say systematic approach to econometric modeling. So, now the moment you will get this particular issue, then obviously there are two steps for you. So, it will give you two different paths to go for the best fitted models. So, means once you get the estimated models, so you are not sure whether this model is perfectly okay for you or not. So, in the to know this particular task, so you have two different path, and ultimately you have to go two different path, and finally you will come to a conclusion. That means you have to start from here this side, and you have to start from this side. Ultimately you will join some place, then ultimately you will get the, you can say, conclusions. So, this particular side is called as a specification test. So, we in this side we have to check this specification. You have to go for specification test. In this sides you have to go for goodness fit test, GFT, goodness fit test. It is otherwise called as a ST, specification test. So, once you have the estimated models, so the moment you get the estimated model, then of course you have to test it whether it is considered as the best models and can be used for policy purpose. So, for that, so you have to go for specification test and goodness fit test. So, specification test, what is mean by specification test? That means the specification test is nothing but to judge the significance of the parameters. Significance of the parameters. This idea, the specification test objective is to check whether the parameters are statistically significant, and GFT test is to know the significance of the overall fitness of the model. So, it will give you the significance of overall fitness of the model. Okay, fitness of the model. So, that too it does by R-square and adjusted R-square. Okay. So, R-square is a coefficient of determination, and accordingly we have to see whether the R-square is statistically significant or not. Okay. So, in the specification test we usually use t statistic to check the significance of the parameters, and in the other side for GFT we use F statistic to check the overall fitness of the model. So, that means R square should be statistically significant in the right side for GFT goodness fit test, and in the other side. So, we have to apply t statistics and to know the significance of each parameters at a individual rate. Okay. So, that means we like to know beta 1, beta 2, beta 3 like this individual coefficient should be statistically significant, and for that we have to use t statistics. Okay. And for overall fitness of the test we have to use the R square statistics. So, together we have to see how quickly will we have the solution. If both will go in the same way or as per your expectation, then obviously the model can be considered as the best. So, that means if it is true, okay, if it is true means if the condition is satisfied, and if this condition is satisfied, then we will get the best fitted models. Okay, best fitted model BFM. Okay. So, this particular model is called as a best fitted models. However, in reality the situation is something other way around. That means your expectation is to make the estimated model or to have the best fitted models as per the significance of the parameters and overall fitness of the models. This is your expectation, but it may not be possible. Okay. Sometimes there may be some of the components which you can say divert from that objectives. So, what are these situations? So, that situation may lead to serious issues or serious problems in the econometric modeling. Okay. So, that means now we have two different specifications. Okay. So, means two different altogether problems. Okay. So, what is the problem? First problem is, so that means when we will call the model best fitted models, then it must fulfill two conditions. Okay. First condition, all the parameters, means first condition is all the parameters should be statistically significant, and R square must be statistically significant at a higher rate. Okay. So, that means F statistic, statistics should be absolutely very high, and here T of all these beta coefficients should be absolutely high, and at the end all the beta heads should be significant at the high rate, and at the end all means the R square itself will be highly significant at a higher rate. If not, then there is a problem, and that means that model cannot be considered as the best fitted model. So, that means now the question is what are such problems. So, then we have to check what are the possibilities. From these possibilities you will face the problem. So, that means we have two different components altogether. One is the significance of parameters and overall fitness of the models. So, now there are few chances that all parameters cannot be statistically significant, or you can say R square cannot be statistically significant. So, in the first case, if few betas are significant, and R squares followed by F is significant, is highly significant, highly significant. Okay, highly significant, and R square followed by F is highly significant. That means here we are we are going together. Okay. So, that means we are going overall fitness of the model, and we are going the specification test. So, that means in the first, if all these betas are significant and R square is significant, then we have the best fitted models. Okay. So, we have to go ahead with this problem, means a forecasting issue, etc. But if few betas are significant and R square is satisfied here very high and highly significant, then the problem is very complex. You cannot say that this model will be considered as the best. Okay. This is one such issue where model cannot be considered as the best. Okay. Second issue, if all betas are significant and R squares followed by f is relatively very low and not significant respectively. Okay. So, that means you see here all the parameters should be significant and R square should be significant. So, now if not, then there are two different possibilities. So, first possibility is, let us say out of all betas, few betas are significant, and other sides R square is substantially very high. That means substantially very high means the value of R square will be very close to 1. Okay. It tends to means it very close to 1. Okay. So, that means it is extreme end. So, then and if it is coming extreme end, then obviously f will be accordingly very high. Okay. Because f is the function of R square. So, that means f statistics depend upon the values of R square. If R square is very high, then f will be by default very high. If R square is very low, then by default f is very low. So, that means R square is a very strong component, is considered as a strong component to check this particular issue. So, that means if by any chance if few betas are not significant and in the same times R square is very high and f is very high, means R square is highly significant, then there is a serious problem. So, in that case model cannot be considered as the best. This is one option or the one such problems. And second such problem is, let us assume that all betas are statistically significant, but on the other side R square is very low and followed by f is also very low and also not statistically significant or statistically significant at very low rate. Okay. So, that means in that case the problem cannot be considered as the best. Okay. So, what is the final conclusions? So, final conclusion is this model, estimated model, has to be re-estimated again to get the model again best fitted. Okay. So, this is how the process is all about. But now for this particular setup, so far as the first part is concerned, it is very frequent in the econometric models. Okay. Means there is a possibility that few betas are significant and few betas are not significant. Okay. So, that means if say out of 5, if 3 betas are significant, 2 betas are not significant, or vice versa, and in the same times R square will be relatively very high and followed by f is relatively very high. But if betas are, but in the second case, if betas are significant, all betas are significant and R square is very low and followed by, you can say, f statistic is very low, then in that case this means it is very rare situation, it is very occasional and very exceptional. Okay. It is a totally very exceptional. That means why it is so exceptional? You see here, when we will go for R square statistics, R square, because here why exceptional? So, in the first case beta heads are all significant, Okay. This is the first instant. Okay. Then in the second case, R square and f, okay, or adjusted R square f. So, R square is calculated by the ratio between ESS by TSS. Okay. So, adjusted R square is 1 minus R square into n minus 1 by n minus k. Okay. And similarly, f is calculated by the ratio between ESS by RSS. Okay. But you remember, ESS is a function of, basically the function of x's only. Okay. So, that means the value of ESS depends upon the structure of x only, means the status of x only. What is ESS? ESS means explain sum squares. Okay. So, now explain sum square and total sum square. So, when we will calculate R square, then obviously we have the ratio ESS by TSS, but you know by default TSS is always 1 every times. Okay. Because we have already checked it here. Let us take a case here. So, we start with here y and x. This is dependent variable structure, this is independent variable structures. Okay. This is dependent variable structure and independent variable structure. So, now how means my intention is how quickly we can proceed, you know, one means how quickly we can extend the status of the model, that is from bivariate to multivariate. So, let us the beginning is y and x, that is the initial setup of this econometric model. If it is only one variable, then economic model does not work at all. Okay. So, that means the starting point is obviously two variables, and that too dependent classification, independent classification. So, here we are assuming that y are the series of dependent classification and x are the series of independent classification. So, now in the meantime, you know, particularly today's discussion or last couple of lectures discussion, every time we are assuming that one y with a series of, or you can say one or series of independent variables. So, now if we will start with the one dependent with the one independent, then one dependent with the many independent, then how is the setup and how quickly we can extend, and what are the problems and what are these, you know, serious issues we have to detect there. So, that means if the structure is y with x, then we will call it the bivariate modeling. Okay. So, similarly, let I will in fact instead of x I will put it here x1, because altogether we are discussing here multivariate problem, and this is one of the partition, or this is one of the deductive part of this particular issue. So, now y equal to x1, this is the starting process. Let us say it is a case 1. So, okay, this is case 1 or step 1. Okay. Then next step, so y equal to x1 and x2. So, that means we try to increase one after another variables in the system. So, then in the third case it is x1, x2 and x3. Okay. In the fourth case y is x1, x2, x3, okay, x3, then x4. So, it will be continue like this. Okay. So, that means, so this is bivariate system, then this is trivariate system, then all accordingly it will increase, and we will call as a multivariate systems. Okay. So, now if this can be one model, this can be another model, this can be another model, this can be another models. Now, our approach is bivariate to multivariate, that is how that the entire discussion is the movement from bivariate econometric modeling to multivariate econometric modeling. So, multivariate econometric modeling. So, actually it is better write multivariate econometric modeling. Okay. So, multivariate econometric modeling. So, now what is ultimately a, you know, problem here. So, once you move here, you know, y x1 to y x1 and x2, then y x1, x2, x3, then obviously this system is very accurate and very perfect, how quickly you have to generate this solution and various problems. So, now our issue is here ESS and TSS. You know, TSS is simply summation y squares. Okay. So, that means it is nothing but summation y minus y bar whole square. So, where this is applicable for this model, this is applicable for this model, this is applicable for this model, this is applicable for this model. Okay. So, now whatever your problem size altogether, whether it is, you know, bivariate or trivariate or multivariate, in every case in these similar problems, or you know, just we are adding one after another variables. For instance, I am just going to highlight one problem here, stock price with, you know, its determinants. Means this particular problem we will discuss in the multicollinearity issue. So, now when we will start with the stock price, then you have to find out which one is the most important determinant. Then obviously we have to consider first variable, say x1, that ones. Okay. So, later on we will check it with respect to their significant level of significance. Okay. So, the status of a particular variable can be examined, or weightage of a particular variable can be examined by the estimated coefficients and its the significance levels only. So, by the way we can judge the relative weightage of this particular factor to the dependent variable. So, now in this particular setup, so we like to have a problem here, stock price, then one of the most important determinant is called as a index of industrial production, IIP. Okay. Then there are another variable say money supply, then there are another variable say called as inflation, rate of inflation, then exchange rate. These are the factors which can affect the stock price. This is how we have borrowed from the lots of theoretical knowledge. So, now you see, so now if I will plot all these six variables in this particular sequence, this if it is a stock price, then obviously this should be, you can say, IIP, index of industrial production. Then same stock price, then we are integrating stock of IIP with, let us say, another variable money supply. Then similarly in Y case, so then it is stock price already designated. So, obviously x1 is already designated IIP, x2 is already designated money supply, then x3 is another variable say inflations. Okay. So, this is how we have to add one after another variable, but you remember, once you proceed from one to first to this fourth head, then obviously every time BSE is there, means stock price are there. So, that means what we will go mathematically, every times the left side component is y. So, that means whether you are here or whether you are here or whether you are here, every times you have the same summation y square. Okay. So, it will not vary. However, in the other side ESS will vary. So, that means for this ESS will be something different, for this ESS will be something different. Let it be called it y1 ESS1, ESS2, then this is ESS3, this is called as ESS4, completely different problem, and in the same times we will call it here TSS1, TSS2, TSS3, TSS4. Okay, let us say TSS4. But in this, the TSS1 is this one, TSS2 this one, the TSS is this two, this is the. So, that means here every time y, if you will call it here y1, y2, y3, y4 in that sequence, then every time we are assuming that, or it is by default y1 equal to y2 equal to y3 equal to y4 is equal to say y. Okay. So, this is means one variable. So, every time summation y square is more appropriate to use theirs, but in the other sides, so ESS1, ES2, ESS2, ESS3, ESS4, these are not at all equal. Okay. So, that means here ESS1 not equal to ESS2, not equal to ESS3 and not equal to ESS4. So, that means, so what is the setup of ESS? Explain, that is explain sum squares, explain sum squares. So, that means for this, what is explain sum squares? By basic formula is explain sum square is beta head summation x1 y. Okay. Summation x1 y for this particular models. Okay. For this particular models. So, this particular model beta 1 equal to summation x1 y or y x1. Okay. So, this particular setup is for bivariate models. Okay. So, when you will go for trivariate model, then obviously you have to add another variables. Okay. So, for instance, for the second variable, this ones, then ESS equal to beta, in fact this will be beta 1 head. Okay. Beta 1 head summation x1 y. Okay. So, similarly in this case beta 1 head summation x1 y plus beta 2 head summation x1 beta 2 head summation x2 y. So, this is how the factor has to be added. So, that means once you move one after another, then something will be added into this particular ESS. So, that means the trend of ESS will be start increasing when we will involve one after another independent variables. Let us see here once again. So, the structure is like this. So, now here means y x1, so y x1 x2, then y x1 x3 sorry x2 x3, then y x1 x2 x3 x4. Okay. So, this is I will call it explain sum square ESS1, this I will call it ESS2, then this I will call it ESS3, then this will call ESS4. So, our objective is here it means two specific objective here to for this writing all these components. But first thing is what is the ESS value and how is the trend. Okay. So, the trend will give you whether the trend is constant. So, that means this value, this value, this value are same, or it is increasing trend or decreasing trend, or you can say there is some up and downs. Okay. So, that means increasing, decreasing or decreasing, but out of all these possibilities, most of the cases, or you can say most feasible is that it will be in increasing trend, because by default we will see here it is how is that structure. For ESS 1 it is beta 1 head summation y x1, okay, summation okay, that's better, so we will put like this. Beta, yes, right, that is right, correct, beta 1 head summation y x1. So, this one will be beta 1 head summation y x1 plus beta 2 head summation y x2. Okay. Then in that case ESS 3 equal to beta 1 head summation y x1 plus beta 2 head summation y x2 plus beta 3 head summation y x3. Okay. So, this is how you have to continue. So, that means you see here every time there is a involvement of something extra. Okay. So, now in that case there is something extra. So, similarly in the case of ESS 4 it will be coming like beta 1 head summation y x1 plus beta 2 head summation y x2 plus beta 3 head summation y x3 plus beta 4 head summation y x4. Okay. So, like this. So, now in generalize ESS equal to beta head I summation y xi. Okay, summation y xi, alright, beta 1 head I summation y xi. So, this is how the general format. Of course, it is better you can write like this way, beta I head summation y xi I equal to 1 to n. Okay. So, this is the ES format. So, that means if we plot like this way, this side is x and this side is ESS, then obviously it will increase like this. Okay, it will increase like this. So, that means ESS will be when if you plot like this, let us say this is x1, this is x1, that means variable number of variables introduced in the system. This is x1, x2, this is x1, x2, x3 and so on, like this way. So, that means this is 0.1, 0.2, 0.3, 0.4, 0.5 like this, 0.1 1 variable, 0.2 2 variable, 0.3 3 variable. So, that means when there is one variable, what is ESS, then when there is two variable, what is ESS, then when there is three variable, what is the ESS. So, like that if we plot all these things, then it will be in increasing sequence. So, that means what is our conclusion is that so when we will add one after another variable, ESS cannot be constant, it will increase at a increasing rate. In the same times your y TSS will be remain same, TSS will be remain same. So, that means whether it is y x1 or y x1 and x2 or y x1 x2 x3, in every case your TSS will be same. So, the problem is only for ESS. So, since ESS is changing at an increasing rate and TSS is constant, so by default R square cannot be low and followed by f cannot be insignificant, or f value cannot be low. Okay. The moment we add one after another variable, then obviously by default or by natural process you will get natural process, I mean by mathematical process, it will increase the value of R squares, okay, coefficient determinants or adjusted R square. Similarly, f can also increase, but when you will add one after another variables, then obviously you are introducing another coefficient into the system. So, for instance, for a bivariate setups we have only beta 0 head and beta 1 head. Then when we will go for trivariate, then beta 0 head, beta 1 head, beta 2 head. So, when we will add another variable, then beta 0 head, beta 1 head, beta 2 head, beta 3 head, like beta 4 head, beta 5 head, like this. So, one after another variable you are getting one after another beta coefficient. So, that means the requirement is that so every times whatever coefficients are involved, at what point of time all these coefficients should be highly statistically significant. If not, then there is such problem, serious problems, and that may be one of such problem may be because of multicollinearity issue. So, now the thing is that So, when we add one after another, then obviously TSS will be remain constant, only thing is ES is changing at the increasing rate. So, obviously, so there is the second possibility may not be occur, it is very exceptional case where beta coefficients are highly significant or all are significant, where R is very low and F is very insignificant. So, this second possibility is very exceptional, it is exclusively exceptional, but in the first case it is very rare. So, that means most of the multicollinearity problems will because of this first case. So, that means it is the case where the significance of parameters, few parameters may not be significant, and R square will be on the other side, R square will be very high followed by F statistic, because here when R square is high, then obviously F will be high, which we have highlighted already, because you see here F is a function of RSS by ESS. Okay, so divide this is nothing but, if you simplify, then this is nothing but 1 by 1 minus R square divided by n minus 1 by n minus k. Of course it has a degrees of freedom here, this is n minus 1 and this is n minus k. Okay, so this is how the structure altogether. All right, so now within that particular framework, so we like to highlight what is all about this multicollinearity problems. Okay, so let us see what is the structure of multicollinearity. So, with this basic background, so we have to enter the issue of multicollinearity. It is a very strong component and very serious issue so far as a multivariate model is concerned. Until unless you go to that particular problem, then the problem cannot be considered as the best fitted model. It is one of the serious problem. It is one of the serious problems in the case of multicollinearity, multivariate model. So, when we will handle the multivariate problem, then obviously one of such problem it is mandatory that you have to check the multicollinearity, otherwise this model cannot be considered as the best fitted model. Okay. So, now what is this exact problem of multicollinearity? So, that means we like to now discuss various structure and issues of multicollinearity. So, what are the structures? So, that means why we like to know first what is all about multicollinearity. What is all about multicollinearity? Okay. Second issue is what are the causes? What are the causes behind multicollinearity? What are the causes behind multicollinearity? Okay. This is second problem we have to discuss. Then what are the consequences? What are the consequences due to multicollinearity? Due to multicollinearity issue. Okay. Fourth is how to detect. Okay. So, far as the detection is concerned, means detection of multicollinearity problem is concerned, there are very standard rules. Some of the rules by inspection you can observe, or you can say some of the points you can highlight there. You can highlight that there is a multicollinearity problem. So, that means this is by inspection only, and everybody cannot judge or cannot put remarks or can identify such type of problem until unless you use a great statistician or econometricians. So, once you have a sufficient knowledge on about this statistics and econometrics, then by look you can say that this problem this is the models which has severe multicollinearity problem or minor multicollinearity problem. Okay. The second issue is fourth issue is how to detect this, and so some of the detection is very easy, some of the detections are very complex. For that you have to go for simple typical procedural measures how to check the multicollinearity. Okay. So, then 5 is solution to multicollinearity. Okay, solution to multicollinearity. So, that means here it is means how to detect the multicollinearity. This we can fill up multicollinearity. Okay. So far as the solution is concerned, you see here. So once you detect the multicollinearity, then obviously there are two questions in your mind. First question is it a natural problem, or is it a technical difficulty, or artificially you are creating that problem? So this answer is very complex. Some of the problems by natural process there will be multicollinearity problem, and some of the artificial it can be done, by either by knowingly or unknowingly. I will highlight what are the cases you can knowingly brings the multicollinearity problem, and sometimes there may be unknowingly the problem of multicollinearity is coming. So means both are artificials, means you are the culprit to generate the multicollinearity. But you remember one thing, why I am using the term culprit, because multicollinearity is problem part of this econometric modeling. So it is just like a virus. Okay, so that virus has to be either clean totally, if not then you have to clean at the certain level, so that the model can be used for best fitted. All right. So now let us assume that the multicollinearity is a serious problem, then obviously by default you need to find out some solutions. So that means just like a virus, it will totally make your system inconsistent or stagnant. You cannot run, you cannot work anything. So that means you need to cure it. So that means you need to find out a package, software package, so that the virus can be totally removed. So that is one of the way how you have to go for the solution. Another trick is, some of the virus may be in one particular area. So still the model by overall at the broad level it can work. Okay. So that means sometimes multicollinearity may be there, but you have to go ahead with the forecasting or policy use. So now to make a judgment whether this is okay or that is okay, so it is a very serious issue, and for that you need to know what is your objective, what is your problem, and how, whether you are creating artificially, or you can say that to knowingly or unknowingly. These are the factors should be in front of you, then you can make a judgment whether you have to go ahead with the multicollinearity problem, or you have to find out its a complete solution. For instance, you see here multicollinearity, the standard definition of multicollinearity is that the linear relationship among independent variable, that is to with respect to regressors. One of the standard regions, we will discuss details what are the various regions, but one of the standard regions, since we are discussing one of the component about solution, one of the standard region is that the involvement of various independent variable in the systems for a particular dependent variables. It is very tough for a researcher. He may not be statistician, may not be econometrician, to find a variable which is exactly influence the dependent variables, or to find out few variables which is exactly determined by dependent variables. If that is the case, then obviously econometric has a zero role. That means the way we are expecting that there should be error component and there should be explained component, then there will be total component. If error will be 0, then obviously the problem complexity will be over there. So that means the game will be over there. The game will be very interesting when there is some type of error component. So that means, so your objective every time how to minimize the error. So of course if you get error free component, then your journey is end there, but you will not you will get different type of satisfaction if you will have problem, and in the by the way you have to get its solution. So that is one way very interesting, but it is a very frustrating also. but that is one type of very enjoyment, and that is what is econometric modeling all about. So, econometric modeling means the moment you will be entering, so you are expecting that everywhere there is a problem. So, every time you have to find out the solutions. Nowhere you will get the concrete solutions. So, if you will find solution for something, then there will be additional problem for something. So, at a very last stage you can get a solution by compromising so many things in your problems or with respect to various objectives. Okay. So, why I have mentioned this issue? For instance, for a particular variable, because you are not sure which variables are exactly influencing the dependent variable. So, you are adding one after another. Then you will find the model itself, estimated model is giving very nonsense results. For instance, very few significant R-square, very few significant parameters, and very high R-square. Then obviously this model is totally unfit and cannot be considered as a policy use or forecasting, etc. So, that means you are in sure that some variables, because of some variables this system is totally in the rough side. So, you have to check or you have to detect which particular variable is more culprit to damage this particular environment. So, you have to remove that one. That is how the objective all about for multicollinearity. This is what artificial, and that too sometimes unknowingly issue. Okay. Unknowingly issue means because you have no idea previously, then by the process of statistical investigation you come to a conclusions. Okay. But sometimes knowingly you can create such problems. Take a case of time series modeling. We have various component under time series modeling. So, when we will go for time series modeling, so we start with one variable, then we create series of various variables. For instance, let us say variable yt is considered as a variable for time series modeling. Then you have to create various independent variable like yt minus 1, yt minus 2, like yt minus k. So, now there when we will fit yt as a function of yt minus 1, yt minus 2 up to yt minus k, then obviously there may be possibility that yt minus 1 as a function of yt minus 2, yt minus 3, yt minus k, again yt 3 minus 3 may be also function of yt 4 minus, or vice versa, yt t minus 3 may be function of yt minus 2 or t minus 1 or yt. So, there are various such problems are there. So, this particular problem, because we need to have such type of time series framework or time series modeling is all about that structure. So, that times you artificially create variable and you have to find a trade solution, because the game and problem is completely different angles and different setup. So, that is why you know that there will be obviously multicollinearity problem, still you are going with that particular problem. So, that time your objective is something different, not for multicollinearity issue, but by default you will be getting the multicollinearity. But in this particularly in the cross sectional modeling setup, so here you cannot artificially create such a multicollinearity, because there is no such way to create artificially, but most of the cases unknowingly you generate some multicollinearity problem, but over the time frame you have to find out the solution. So far as the details, the structure of multicollinearity solution is concerned, we will discuss in the next class. With this we have to conclude this session. Thank you very much. Have a nice day.